So last time we were looking at what it means to add up infinitely many things. The technical name for that is a series. So we have some list of numbers and we want to add them all up so long as that's even a sensible thing to do. We can't add up a list where each number on the list is 1 and the list goes on forever. That's going to diverge. The way that we decided whether or not a series makes sense, whether or not this infinite sum actually tends to some value that we can compute, well, we just did that in terms of limits. Now, last time we had a formula for the geometric series. It is a fairly common series and a very nice one to work with specifically because of that formula. If I'm adding up a bunch of numbers and each number on the list is a multiple of the number that came before, and it's the same multiplier every single time, that's a geometric series. And we can immediately know whether or not it converges or diverges just based off of what that multiplier is. I know that adding up a third plus a ninth plus 1/27th plus 1/81st and so on, that's a geometric series. The first number in the series is a third. The common ratio is also a third. So I know that converges, and I even have a formula for what number that sum will be equal to. Now, not every series is a geometric series. There's far more complicated formulas we could throw together and try to evaluate. So we'll want some tests to tell us quickly whether or not those other series converge or diverge. So, like everything else in this class, we want to figure out a new trick, and we are going to do it by rephrasing the problem in terms of something else that we already understand, or at least something else that came up previously in this class or in a math class earlier than that. So our general strategy in university mathematics is to take a hard problem, take a new problem that's interesting, that might come up when we are working in our majors, when we're working in our professions, and turn it into an easier problem using mathematics from the recent past. And so for this reason, mathematics sort of builds up on itself. Over time, we need to be familiar with the older kinds of things that have been coming up in calculus so that we can then move on to solve the newer problems. Today, I'm going to be talking about how to tell whether or not a series converges based off of improper integrals. So a couple of weeks ago now, we were looking at how to evaluate a definite integral, but what if the integral that I want is not on a finite interval? So we called those improper integrals. We had to calculate them using limits. We have not escaped from using limits. They're still kicking around. And we're going to use that technique for series instead.